Considering we have already discovered hundreds of exoplanets, we can't help but wonder if a real Earth analog has already been discovered. On 18th April 2013, astronomers from the Kepler team announced a discovery that created great expectation. For the first time ever, two very Earth-like exoplanets were found. They were the Kepler 62e and the Kepler 62f. And orbits Kepler 62, an orange dwarf star, in its circumstellar habitable zone. They immediately became prime candidates to host alien life. A modeling study also concluded that Kepler 62e and Kepler 62f are likely covered mostly, perhaps completely, in water. Kepler 62e probably has a very cloudy sky and is warm and humid all the way to the polar regions. Kepler 62f would be cooler, but still potentially life-friendly. Unfortunately, they are at a huge distance of 1,200 light-years away in the constellation of Lyra. Soon after, it was discovered an exoplanet even more similar to Earth, Kepler 186f. This finding was a milestone, as it was the first rocky planet found in the habitable zone of its system. It is 492 light-years away from the Earth.
Kepler 186f is possibly my favorite planet to come out of the Kepler mission. It's a small planet. It's maybe 10 to 20% bigger than the Earth. Based on everything we know about planets, it's almost certainly to be rocky. And it's the right distance away from its parent star that, if the atmosphere is right, if the greenhouse effect is right, it could have liquid water on the surface.
After that discovery, several more Earth-like candidates started to arise, like Kepler 438b, Kepler 442b, or Kepler 440b. All of them were very similar to our planet, but none of them was a real twin Earth. But everything changed on July 23, 2015. That day, NASA's Kepler Space Telescope science team shocked the scientific community with an amazing finding. The most Earth-like planet ever was discovered. Its name, Kepler 452b. What made different this one to the other previous Earth analog candidates? Kepler 452b is the very first, apparently rocky planet that orbits a G-type star like our Sun.
It's a planet in the habitable zone around a star which is almost a clone of our own Sun.
After this discovery, the Earth is a little less lonely in the universe. Kepler 452b circles its star, which is about as hot as our Sun, 10% brighter and 20% larger, at an orbital radius just 5% larger than that of the Earth. A year on this planet is 385 Earth days long, just 20 days longer than Earth's.
What makes this slightly less exciting from the point of view as could it be habitable is its size. Our best guess at the size is that it's about 60% bigger than our own Earth.
It is the smallest Earth analog planet ever found in the habitable zone of a G-type star like our Sun. Previous research on super Earth-sized planets like 452b suggests this one has a good chance of being rocky. If it is a rocky world, it weigh in at about 5 Earth masses, giving it a surface gravity of roughly 2 grams, which would mean that our weight would be double on its surface. Kepler 452b could have a thick, cloudy atmosphere and volcanic activity. Even more exciting than Kepler 452b's Earth-like demeanor is the fact that this world has spent around 6 billion years in the habitable zone of its star. That's considerable time for life to arise somewhere on its surface or in its oceans, should the conditions for life exist. Kepler 452b is about 1.5 billion years older than the Earth. If it was Earth-sized, the planet and its aging, brightening star might be at a point in their evolution where liquid water would be rapidly evaporating from the surface. But because of its higher mass, astronomers believe Kepler 452b could continue to hold liquid water for the next 500 million years or so. So far, it's the only known world in the system, which lies some 1,400 light-years away in the Cygnus constellation. Obviously, we're not going to get there anytime soon, but it's fascinating to imagine that far off in the distant reaches of space, a world very much like our own might already exist. If this twin Earth exists, why couldn't thousands more like it exist? Less than a year after the amazing finding of Kepler 452b, on May 2016, a new discovery shocked the scientific community. Astronomers using telescopes at European Southern Observatory in Chile discovered 3 planets around a dim dwarf star just 40 light-years from Earth in the constellation of Aquarius. These worlds may be the best targets so far found in the hunt for life elsewhere in the universe. They used the TRAPPIST telescope to monitor the brightness of an ultra-cool dwarf star in the constellation of Aquarius, which has been named TRAPPIST-1. TRAPPIST-1 is much cooler and redder than the Sun and barely larger than Jupiter. Stars like this are very common in the Milky Way, and they are very long-lived. This was the first time that planets have been found around one of them. The 3 planets are very similar in size to the Earth and might have habitable regions on their surfaces. But the really exciting result is that these are the first Earth-like planets that are well suited for the detection of life. The ultra-cool dwarf stars are the only places where life could be detected on an Earth-sized exoplanet using our current technology. The light from much brighter star, like the Sun for example, would swamp vital measurements of the atmospheres of any candidate planets. The next step is to make more detailed observations using the next generation of telescopes, such as ESO's, European Extremely Large Telescope, and the James Webb Space Telescope. That will allow astronomers to study the atmospheres of planets like this and to search for molecules related to biological activity, like ozone, methane, or water. Although there is not yet any proof of the existence of life on all of these exoplanets that we've already found, even in the most Earth-like of them, like Kepler 452b, we can't help but wonder if any of those potential forms of life that might have arisen there were or will be able to evolve into intelligent life. If any of those extremely remote worlds was formed billions of years ago, as Earth did, and it became into a habitable planet, then the organic compound had time enough to mix up and organize into living forms. Perhaps any of those living forms might have evolved into complex forms of life, and some of those complex forms of life might evolve into intelligent beings with consciousness. Thanks to Kepler Mission research, it's known that just in our galaxy, the Milky Way, there might be millions of Earth analogs, and there are billions of galaxies across the universe. So the chances are much higher than we could have ever imagined. For that reason, science is carrying out an intense search for intelligent life. The SETI Institute in California is nowadays the main world institution devoted to the search for extraterrestrial intelligence. Its name, SETI, stands for Search for Extraterrestrial Intelligence. This search is based on the use of radio telescopes. Radio telescopes receive radio waves. As we can't go to space aboard spacecrafts to find that intelligent life, what we look for are radio signals.
What we're looking for is a signal that's at one spot on the radio dial. Just like when you're listening to the radio in your car. You know, you tune across the dial, you hear static everywhere, and then at one spot you're near, and there's a station. Okay, that's the signal that's produced by a transmitter somewhere. It's not natural static. It's not like a quasar or a pulsar or galaxies or hot gas, cold gas. All those things in space make radio noise, but it's all over the dial. So we look for signals that are at one spot on the dial, and of course the source of the signal has to be up in the sky. Those are the kinds of criteria we use to know that even if we don't know what it means, we at least know they're there. They're on the air.
Unfortunately, till now, we haven't received a signal that can be really attributed to extraterrestrial intelligence.